So in this week's video, we're going to be going over the 19th LeetCode problem, remove nth node from the end. Now this is a very popular programming question that is asked by numerous companies like Amazon and Microsoft, and on occasion by companies like Google and Facebook as well. So let's dive right in by reading the problem statement. Given a linked list, remove the nth node from the end of the list and return its head. Let's take this example. So we're given this linked list 1, 2, 3, 4, and 5. And we're given n, which is equal to 2. Now we want to remove the nth from the end node in this list. So even though we're given 2, we don't want to remove the second node. We want to remove the second from the end node in this list. So that in that case, it's going to be 4. So the resulting list, after removing the second from the end node, is going to be 1, 2, 3, and 5. Now, an important thing to note is that we're going to be given that n is always valid. So we don't have to worry about weird edge cases. Now, in the real interview, you may have to worry about these edge cases, but for the purpose of this problem, we're not going to be worrying about that right now. So let's get started by coming up with an algorithm that will help us solve this problem. So we're given this linked list where the head points to the first value, and we want to remove the second from the last node in the list in this case. So to do that, we can't actually start from the end and traverse backwards because there's no pointer that points to the end. What we really have to do is find the complement of n. So let's say we have to find the value k, and k is going to be equal to the number from the beginning of the list. To find the number from the beginning of the list, we have to count how many nodes exist in the linked list. In this case, it's 5, and we want to subtract n from this value to get k. So 5 minus 2 equals 3. So we know that 3 represents the number from the beginning of the array. Once we have this value, we can easily remove the node. Since k is equal to 3, we want to find the fourth value in this list because we're going to be starting the count from 0. So 0, 1, 2, 3. So this is the node that we want to remove. We know that we can't lose the reference to the head of this linked list. So what we can do instead is have a pointer that points to this list, and it iterates in a while loop until k is equal to 0. So while k is not equal to 0, we can decrement k and we can increment ptr. Cool. So this second section of this problem is going to help us find the actual node that we need to remove, and that's where ptr is going to point. Now this gives us a question: how can we actually remove this node from the list if ptr is pointing here? So that brings us to the third part of this problem. So there's only one way to remove a value from a linked list, and that is to have a pointer that is pointing to that value not point to that value anymore. So in this case, we're actually going to need to have two pointers. So we're going to have a previous pointer that is always going to be one step behind ptr. So it's always going to be one step behind ptr, and this way, when we have a reference to the previous pointer, we can easily change this value of 3's next to equal to 5. And now there is no way to get to 4. So this is pretty much gone. And of course, now 4 technically will still be pointing here. And what we can do is remove the reference of 4's next pointing to 5. So now it's just an empty node in empty space. And so this is the third portion of the step where we have a prev value, and all we have to say is prev.next is equal to ptr.next. And PTR's next is going to equal none. And at the end, we've removed 4 from the list, and we can easily return the head of the linked list. Pretty straightforward. And when we're thinking about the time complexity of this algorithm, we know initially that we already traversed the list once. That is just to get the value of k. And once we have traversed the list once, we have to traverse it one more time in the worst case, because we have to iterate PTR to that section of the list that we want to remove. And of course, move the pointer like this. So that's just going to be given a big O of n plus n, which is of course big O of n. And in terms of space complexity, we know that all we're doing is storing 3 extra values. Regardless of how large the input is, we're only going to be storing these 3 values, and maybe a few other variables here or there. So we have a constant space and a linear time algorithm to solve this problem. Cool, now that we understand the big O and the algorithm that can help us solve this problem, we can take a look at the code. So there's 3 steps that we have to cover. The first is finding the proper index of the node that we want to remove. Because we're going to be given n, which is the value from the end of the list, we want to find k, which is going to be the complement, or the value from the beginning of the list that we have to remove. Afterwards, we want to go to that specific node using a while loop, and of course remove that node. Let's dive into these steps. Initially, we're going to have a temporary variable that's going to be equal to the head of the linked list. All we're going to do is iterate through the entire linked list and count the number of nodes. So we have a number of nodes, which is equal to 0, and we're going to iterate through with the temporary pointer while it's not equal to none, of course. And we just keep going and we keep counting the number of nodes in the list. So once we have the number of nodes, we can get k, which is the index of the node that we want to remove, by subtracting n from the total number of nodes. In the example case, we have 5 nodes and n is equal to 2. So what we can do is say that k is going to equal 5 minus 2, which is 3. If we traverse 0, 1, 2, 3, that's going to be the node that we will want to remove. And that's what we're going to be doing here, is we're going to be traversing through the linked list and have 2 pointers, previous and a current pointer. And we're going to iterate through in the loop, and all we're going to say is that the previous pointer is going to be 1 behind the current pointer. By the end of this loop, PTR is going to be equal, or it's going to be pointing to the node that we want to remove. And previous is going to be pointing to the node previous to the node that we want to remove. And of course, this is how it's done in linked lists, because we need to do some pointer manipulation. The third and final step is going to be removing the node. Now, there's one special case that can occur, which is that if previous is equal to none. So if previous is equal to none, that means that we are removing the first node in the list. There is no other way the previous can be none, right? Because it's only none if it does not enter this entire loop, at which point k is already equal to 0. So in that case, all we have to do is return the head of the linked list. Previous is not equal to none, then we just have to do some simple pointer manipulation. In this case, we're going to say that previous next is equal to PTR's next. So in this case, 3's next value is not going to be equal to 4. It's going to be equal to whatever 4's next value is, which in this case is 5. And of course, PTR's next value is equal to none. This is not really necessary, but I'm going to do it anyway because we don't want 4 pointing here, because that's just weird. And of course, we just have to return the head at the end. Cool, so that's the problem at hand. Now, let's just try to see if this works. And of course, it does work. I can't believe it took 24 milliseconds to run this. Sometimes my computer is super slow, sometimes it's super fast. I was able to hand in this exact same solution and get 8 milliseconds, which was faster than 99% of all Python submissions, which is insane. Yeah. Anyway, that's that. Hope you guys enjoyed. If you did, leave a like and a subscribe for more in the future. And I'll catch you guys next time.